Math logic is already hard enough, and now we have quantifiers. What are those?
Don't worry, quantifiers are actually something we use every day.
Oh, really?
Of course, when you say all students are present or some students are absent, you are already using quantifiers. A quantifier is a way to state or indicate how many elements in a set satisfy in a given condition. The phrases for every or for some are set to quantify the open statement that contains a variable such as x.
There are two types of quantifier. One is universal quantifier and second is existential quantifier. The statement of universal quantifier can be expressed by using for all x, for any x, for each x, for every x. The existential quantifier can be expressed such as for some x, for at least one x, there exists an x such that. Let's take a look at example 1. Consider the following statement. For all x, qx implies sx. Replace the x by 1 and we will find that q1 is true and s1 is false. Thus, the statement is false and consequently, the quantified statement is false.
Is everyone present today? Yes!
Let's take a look at example 2. Consider the following statement. For some x, px and rx. Let's use the number 4 as the number of universe. Substitute the number 4 into the statement and see if the equation is right or wrong. We could see that both the statement is P4 and R4 are true. Then, the statement is true. Let's take a look.
Who has finished the assignment? Me!
I understand those two, but what are nested quantifiers?
Nested quantifiers happen when more than one quantifier is used in a step.
A mathematical statement may involve more than one quantifier. In order to solve that statement, we are going to learn about nested quantifiers. With the first example. In the first example, the statement will begin with universal quantifier followed by existential quantifier. We denote x as student and y as lecturer. So, every student has a lecturer. For all x, there exists y such that L xy. It means for every student, there exists at least one lecturer.
I teach every student in this class.
We are going to continue for the second example. In this example, the statement will begin with existential quantifier followed by universal quantifier. There exists a lecturer who teaches all students. There exists y for all x such that L xy. It means there is one lecturer who teaches every student.
Each student may have a different lecturer.
Now, I'm going to explain a little bit more about nested quantifier. As we can see, there is two statements, where the first statement is for all x, there exists y, such that L xy, and the second statement is there exists y for all x such that L xy. When a statement involves both existential and universal quantifier, these two statements actually have a different meanings, so we must be careful about the order in which the quantifiers are written. We must read the quantifiers from left to right.
Let's take a deeper look into nested quantifier.
Now, let's go to a question of a nested quantifier and identify if the statement is true or false. First, let Pxy denoted as x plus y equals to 17, and the universe set is integers. The first statement says that for every integer x, there exists an integer y such that x plus y equals to 17. This statement is true because once the integer is selected, y equals to 17 minus x does exist, and x plus y will be equal to x plus 17 minus x if we put the value of y inside of y, and it will be equals to 17. Now, let's consider the second statement. This statement will be read as there exists an integer y so that for all integers x plus y equals to 17. As we can see, the statement is false because once an integer y is selected, the only value that x can have is 17 minus 1.
What if we want to express the opposite of a statement?
Then we use negation.
Next, I will explain about negation of quantifier. We have 4 rules for a negation statement with one quantifier. First, negate for all p as equivalent to for some negate p as. Second, negate for some p as equivalent to for all negate p as. Third, negate for all negate p as equivalent to for some double negation p as. And if we simplify, we will get for some p as. And lastly, number 4, negate for some negate p as equivalent to for all double negation p as. And again, if we simplify, we will get for all p as. Okay, so example 1. The statement is all students pass MAT222, which is for all p as. And if we negate the statement, we will get for some negate p as, which means there exists at least one student who did not pass MAT222.
All students pass MAT222.
Not really. One student failed.
Okay, so we go to example 3. The statement is there is at least one student who is mad with the lecturer because the lecturer arrived late for the class, which is for some s p as. And if we negate it once again, we will get for all s negate p as, meaning no student is mad at the lecturer because the lecturer come late for the class. Oh no, I'm already late for the class. The student must be mad at me.
Hello guys. Hi Miss.
Now, let's look at example question for negation of quantifier.
For example 3, the given statement is for all x, there exists a y such that p of xy and q of xy implies to r of xy. Step 1. We have to negate the whole statement. We start by placing a negation in front of the entire statement. Step 2. We have to change the quantifier. When a statement is negated, universal quantifier become existential quantifier and existential quantifier become universal quantifier. Step 3. We have to remove the implication. We use the implication rule where A implies B is equivalent to not or B. Step 4. We have to apply De Morgan's law. Using De Morgan's law, the negation of disjunction becomes a conjunction. Last step is simplify the double negation, which we have to cancel out the negate symbol. Therefore, the final answer is there exists an x such that for every y, p of xy and q of xy and not r and xy.
Oh, now I understand.
Easy, right?
Easy.
In conclusion, quantifiers are used to express quantity and existence in mathematical logic. So, today we have learned about universal quantifier, existential quantifier, nested quantifier, and negation of quantifier. And understanding quantifier help us represent logical statements more precisely in mathematics. 1, 2, 3. Thank you for watching. Bye.